Alright guys, so we're gonna do some notes to learn how to graph logarithm and exponential functions. So let's start with something that we probably talked about maybe at the beginning of the school year. If I have something like this, y equals 3 to the x, do you remember what family that is? I think we remember saying like if the exponent is where the variable is, then this is the exponential family. My next question is, do you remember what the exponential graph looks like? Let's test this out. So if we just set up a table, for x, y, we can plug in some different variables or different inputs. So we could go like -2, -1, 0, 1, 2. Let's try those for now. So if I wanted to plug those in, I would say, here's my function, right? So my x is my input. So I'd say 3 to the -2 power equals y. And 3 to the -2 power is the same as 1 over 3 to the +2 power, which is 1 over 9. So when I plug in -2, I get 1/9 out. What if I plug in -1? I think that's 1 over 3 to the +1, which is 1/3. What if I plug in 0? Anything to the 0 power is 1. So if I plug in 0, I get 1. And what about 3 to the 1 power? That would be 3. And 3 squared would be 9. So these ordered pairs can be used to create our graph. So let's create a little graph here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that'll be good. Maybe. So let's plot these points. So if we go -2 and 1/9, that means I go left 2 and up just a little bit, 1/9 maybe. And this one would be -1 up 1/3, so just a little higher. And then 0, 1 would go right here. 1, 3 right here. And 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. So if I connect all those dots, we get the graph of the exponential. If you guys remember, it looks like this, and it gets closer and closer and closer to this x-axis, but never actually touches it. So we remember we call this an asymptote, where it's getting closer and closer and closer, but never actually crosses or touches it. So that's the graph of our exponential family. So my next question is, how would I graph the inverse of this function? Well, that's what we just had our quiz on, our inverses. So if you guys remember, what we can do to find the inverse is we can switch the x and y, then solve for y. So I could write, instead of y equals 3 to the x power, I could say that's the x equals 3 to the y power. So how do I get y alone now? So if you guys remember, we learned a new function recently that can get an exponent alone. Remember, we could write this as log base 3 of x equals y. This is the drop the base, remember? So if we rewrite it in this logarithm form, this is the equation of our inverse function. So this graph right here is what the exponential family looks like. So let's recap really quick. The parent graph, there's a couple of key features for exponential. And we know this is exponential because of this exponent has our variable. So our parent graph, it has a horizontal asymptote at y equals 0. It also will always have this point right here, our parent graph will, even if our base is something different, like if it's 2 to the x, we still have this point. There's a point at 0, 1. Like I said, that will be true even if there's a different base. So that's true for the exponential. Let's see if there's any key features of the logarithm graph. Well, if we're going to try to graph the inverse, remember we could grab this table. Let's see if I can do that without grabbing the graph. Tricky. Okay. So let's copy that and let's see if we can find the table for our inverse graph. So remember our inverse graph, what we can do, is we can switch spots with the x and y. So my inverse function table is going to be my input is 1/9, my output's -2. My input's 1/3, my output's -1. My input's 1, my output's 0, and my input's 3, my output's 1, and 9, 2. So these are the points that go with this graph, logarithm. So let's see what that looks like. If we go ahead and graph it. So if we graph these points, looks like we have 1/9, -2, maybe there-ish. 1/3, -1, just a little bit more to the right. We got 1, 0, 3, 1, 4, 5, 6, 7, 8, 9, 2. If you notice, it looks like these points all connect together and get closer to this vertical line, x equals 0. So this is what the parent graph of a logarithm looks like. So what are some of those parent graph features that this graph has? Let's see. So parent graph features. If you notice, this time there's a vertical asymptote. Vertical asymptote at x equals 0. So remember, all the x's and all the y's switch. So this vertical asymptote's equation is x equals 0, but before our horizontal asymptote was y equals 0. So even that x and y switch. Okay, so we got a vertical asymptote at x equals 0, and then our key point on the logarithm graph is this one right here. So we'll say point at 1, 0, like this. So this is what our parent graph will look like for the exponential, and this is what my parent graph will look like for logarithm. So if you notice, those graphs are inverses of each other, and they would be symmetrical over that dotted line y equals x. If you remember, I think this is what exponential looks like, something like this. So you can see that those are inverses. So it's really important for today's lesson that you understand what the parent graph of logarithm and exponential look like.